Hey everyone, so this is the second video on recursion, and in this video, I'm going to show you how to write a recursive function. Okay, now I'm going to sort of go through this process, but what's really important for you to learn how to write a recursive function is to write a bunch of recursive functions. No amount of watching people do it is going to help you become a better programmer. So, something that I very much believe in, I'll show you how to do it, the basics, but you need to practice. And it's that practicing that makes you become a better programmer. Okay? Uh, you this applies for all programming, not just recursion, but you really need to practice. Okay? So let's go through this. Okay, what's the process of writing a recursive function? Um, well, first of all, when you write a recursive function, there are certain things that you need to be much more aware of than when you're writing like a normal function. The first step is you really need to know what your function is going to do. So what is your function supposed to be doing? What kind of data are you going to be giving this function? And what is the function supposed to return? You really, really, really need to know this. So is your function going to give you a number back? Is your function going to give you true, false? Is it going to be a list? What happens if you give it a certain value? You really need to understand this before you start writing any recursive function. It is super important, okay? So if you were to pretend that you'd never wrote this function, and you're just trying to make a function call, you would need to know what you're supposed to be giving the function. And what do you expect as the result of that function? You need to know this because you're going to be calling this function because it's recursive. So knowing what the function does, what it accepts, what it returns, that's step one. Step two, take a look at the function and ask yourself, does it support what it is that you're trying to find with the function? So I have two examples I'm going to be doing with you. One is the factorial function and one is the palindrome function. In the case of the factorial function, I'm given a number and I'm trying to find that number, the factorial of that number, right? So I have everything that I need because I just need to know what the number is in order to find the factorial, right? So I'm going to be, so because that is the case, I am going to actually be doing this one without having to alter anything about this function prototype. On the other hand, this is palindrome function. This prototype does not support what it is that I'm trying to do. So, so a palindrome is a word that reads the same backwards and forwards. So, for example, noon, N-O-O-N, is a palindrome because if you read it forward, it's N-O-O-N. If you read it backwards, it's N-O-O-N. So that's a palindrome, right? Now, if you were, so think about how you would write this function iteratively. You would probably have a loop, and it would basically start at both ends. You would have look at the first letter and the last letter, and you would say, well, are they the same? Because if they're not the same, then it's not a palindrome, right? So they have to be the same to be a palindrome. And then you would look at the second letter, the second last letter, are they the same? And then the third letter, third last letter, are they the same? And so on, right? So I need to know where the ends are, and I'm kind of moving towards the middle if I think about this process. So I need to know which letter I'm looking at. Is it the first one, the second one, the third one? But this just gives me the entire word. So how can I tell which letter I'm currently looking at in this particular function, right? So this particular prototype does not support what I'm trying to do. And so I'll need to write is palindrome with a separate prototype, okay? Now, could you maybe work with this and do it? Maybe, but it's probably going to be difficult and it's much easier to just use a separate prototype. Now, some people are going to start saying, well, I can use a static variable. Do not use a static variable. Static variables are not for this, okay? Whatever you need should be in the argument list, not in a static variable, and certainly not in a global variable. So if you're using a global variable, it's wrong. If you're using a static variable, it's probably also wrong. That's not what they're being used for. You need to have the things that you're looking at on the stack. So it needs to come in through the prototype. Okay, so be kind of very careful about how you would approach this problem. So this prototype, not good enough. So we'll use a different one. Now, Let's take and here's another example uh, of this. So here is the merge sort code. So here's the merge sort function, right? Now, just like any other sorting algorithm, you're just trying to sort an array. So the only thing you should be giving it is an array. Unfortunately, the array does not allow you to easily merge sort. Merge sort is an algorithm that basically says merge sort the first half of the array, merge sort the second half of the array, and then you merge them back together, right? So you need to know where the first half of the array is. Where does it begin? Where does it end? And where does the second half begin and end? So when you're doing this merge sorting, you need to know you're not actually trying to sort the whole array. So, like you need to know which section you're trying to sort. And that means you need to know the index of each of the section, like the index. My array begins at array 0, element 0, ends at element 10, whatever it is. We need to know what the indexes are, like what part of the whole array is the array that I'm trying to sort. And because of that, I need to have extra arguments, which this one doesn't have. This one says it's the entire array, right? But when you actually do the work, you are sorting each half and you need to know where they begin and end. You also have this, you also have to use an empty list to do the merging. And you could declare this inside the merge function, but that's going to be very costly. Doing it once here and passing it around like scrap paper is going to be make this a lot more efficient. So in this case, this particular empty list is used to, this particular empty list is going to be used to basically do the merging. So I declare it once here and I pass it into the function so that it could be used, okay? Now, this is why the recursive function has 4 arguments. This is the actual function that does all the work. This function just makes the first function call, and that's it. So initially, I'm sorting everything from index 0 to the end of the last index inclusive. And that's what you pass in to do each of the sorts. So just be aware that sometimes if your prototype doesn't work, maybe you need a different prototype. Once you have decided exactly what your prototype is, you now have to actually write the code. And to do that, the very first thing you need to do is you need to figure out your base case. What argument values can you give your function so that the problem becomes trivial to solve? Okay, so now trivial doesn't mean easy. So some people call this the easy case, but I don't like that word because sometimes the base case is actually harder to code than the recursive cases. So I don't like the term easy case because it seems like, oh, this will be easy to code. That's not true. Okay, base case could be very complicated to code, but you know what the answer is. It's just, it might still be complicated. Okay, once you have established your base case, then you write your recursive case. Okay, so those are sort of the step-by-step methodology. I'm going to do all the 4 steps in each of the examples that I will show you. So let's start with the first one, which is standard recursion example number 1. This particular function is going to find factorial. Now factorial I've defined here. N factorial is n times n minus 1 times n minus 2 all the way down to 1. Now this is, obviously you can do this with a loop, but we want to write this recursively. Now there is a 0 factorial. 0 factorial is equal to 1. Okay, just so that you know, this is by definition. Okay, you can't change this to something else. This is 0 factorial. 1 factorial is also 1, by the way, like because it's 1, that's it, right? There's no, you can't go further than that. So this function is supposed to return number factorial. So how does it work, right? So step 1, what is this supposed to do? Well, you pass in a number and you return number factorial. That's what it's supposed to do. Okay, so know what it is supposed to do first. Step 2, does this argument list support you properly? Well, I'm just trying to find number factorial. I have the number. We're good, right? So I can do this. And this number does not, you can't like just, it's not like you can split this number into like the first 8 bits or last 8 bits or something like weird like that. It's just the number. So I have everything that I need. So just go from here. Next step, what are the base case? What are your what is the base case. Okay, now if I have 0 factorial, I know the answer is 1, right? And I also know that 1 factorial is also 1, right? So my base case is if the number is 0 or 1, that's my base case because I know what the answer is right away. 0 factorial by definition is 1, and 1 factorial, well, it's just 1, right? So I have actually 2 base cases here. Now I can do this check. So 1 factorial is also equal to 1. So I can write this without actually doing anything else. I don't have to worry about any value that is like the base case is just 0 or 1. That's the base case, right? Now there's different ways that I can code this. So there's no one right answer for this. Um, so uh, depends on how you write the code. And you can write it slightly differently and it will still work, okay? So just beware that there is no ever one right solution for any programming problem. There's always going to be multiple, and you might arrive at it slightly differently. So one way I can say this is this. If number is less than or equal to 1, that will cover 0 and 1, right? Then, oh, proper indentation, right? If number is less than or equal to 1, then I'm going to return the number 1. That's my base case, okay? So this is the first thing you always do. Establish what the check for the base case is and what do you give back in the case of the base case, okay? So here's my check for the base case, okay? Less than or equal to 1 will cover 0 and 1. And if it's either 0 or 1, it's 1. That's it. Now, what happens if it's not less than or equal to 1? Then it must be greater than, right? So what do we do then? Well, now we have to think about the recursive case, okay? The recursive case is always going to involve a function called to the same function, but the argument must take you closer to the base case. So this is key. You're trying to get closer to the situation where you will meet the base case, okay? Now, in this case, I want number to get smaller because when I hit 0 or 1, I can stop. That's my base case. So whatever I'm going to do here, number has to get smaller, okay? So how do I make this calculation, okay? So in this case, let's think about what factorial means. So this is n factorial right here, right? Like this expression is n factorial. Now I can certainly state it like this. This is what it is. But if I think about this, I can think about saying, well, you know what? Let's take a look at what this part is. Just that part that I have square bracketed. This part of the code, this is actually n minus 1 factorial. So this is n times n minus 1 factorial, because that's what factorial is. So if I want to find n factorial, I want to calculate n times n minus 1 factorial. Now, how do we do that? Well, I know how to find n. That's easy, return n, right? But I want to return n multiplied by n minus 1 factorial. So how do I find n minus 1 factorial? Well, I have a function. The function factorial finds whatever I pass in's factorial, right? So whatever I give this function, it's going to find me the factorial. So all I'm going to do is I'm going to call it just like every other function that I had. So if I told you, for example, right now, that I wanted to write a program that will calculate the square root of n, what would you do? You would go, well, the math library is import math or whatever it is, I don't remember, and I want the function for calculating factorial, probably sqrt, right? Now, so all I would do is I would make the function call square root, right? And I assume that it works. So that's what you're doing here. You're assuming that your function already works. Now remember, your function does work. Your function works when it's 0 or 1, right? Like you know that the function will, if you gave it 0, even if I don't write this else, okay, if I took this code out, this function works as long as you only give it 0 or 1. This function is actually a working function. as long as you give it 0 or 1. So what I want to do is I want to get to the point where the function works. So here I'm going to simply multiply this by factorial of n minus 1. Or sorry, not n, it's number. My bad. I was using n above. So number, and this is number minus 1. This will get me closer to that working part of the function. I'm giving it a smaller number, right? And this statement is correct because n factorial is n times n minus 1 factorial. I have a function that will tell me this. So I just call it, okay? Now, this is a really, really important idea. We'll come back to this in a moment. We assume that the function works. We're just making a function call, okay? So you need to just know how the function works and you're going to call it, okay? So here we have another function, palindrome. Now this one may be a little bit harder to do because this particular prototype does not support finding a palindrome. So a palindrome, remember, is words like noon. That's a palindrome, is a palindrome. Okay? Loony is not a palindrome. Okay, so like our coin is not a palindrome because it doesn't read backwards, forwards the same. Now, as I said in the earlier part of this video, this particular function prototype doesn't help me find the palindrome. So what I'm actually going to do is I'm going to write a different function. I'm going to call it find check palindrome. In C, you can use the same function name. In Python, you can't. So there we go. And in this case, I'm going to be passing in the same word, but I'm going to pass in first and last as indexes, first index, last index. Okay, and this is basically the indexes of the letters that I'm going to be checking. So the idea is this. I have a word like, for example, noon. And what I'm going to do is I'm going to call this first index, and this one is last indexed, okay? And I'm going to see if they are the same. And if they are the same, that means it's okay so far. Now, if it's not the same, I already know it's going to be the same. So if I were to, for example, pass in loony, I look at the first, and I look at the last. And those in that situation, those are not matching letters. So I don't have to check the rest of it. I already know this is bad, right? So in the case of noon, when I check it, it's good. In the case of loony, when I check it, it's bad. So I already know that I don't have to keep checking. Now, so this is what I'm basically passing in initially. So I'm going to find out how long my string is. I'm going to pass in the letters I wanted to look at first, and then I'm going to just look. So that's what it will do. So in this function, what I'm going to do is I'm going to return check palindrome, whatever that is. I'm going to pass in the word. I'm going to pass in the first index, which is 0, and the last index, which is going to be len of word minus 1. So that's how I'm going to begin. I'm going to do that function call. Whatever the check palindrome function returns, I just return it back because that's all I need to do. So this is the recursive function that does the work. This is the function that people call, okay? So how do I then write this function? And I'm missing colons, sorry. Syntax is not my forte. All right, here we go. So let's see what we would do to check this palindrome. So let's think about the base cases. What are some of the base cases? So as I said, well, if the letters don't match, that's actually a base case. We don't have to check further. If the letters don't match like this, I'm done, right? So what I'm going to do first is I'm going to make that base case check. If word sub first index is not equal to word sub last index, then this whole thing is false. So return false. Done. Okay. Now, is that the only base case? The answer is no. There's actually another base case. Okay. Now, imagine that I'm doing this, right? So for this one, for example, okay, I check the first two, it is the same. So what do? Well, I'm going to take these two and basically say, well, let's move each of these closer together, right? Now, at this point, I still need to do a check, right? So they're the same. We do it again. What happens next? Well, according to the thing, I'm actually going to be moving this one ahead, and this one further down, right? So at some point, these two are going to cross each other, okay? When they cross each other, that means everything has been checked, right? So when last index becomes smaller than first index, everything is good. Now, there are some letters that there's some words where it might be um, like where it's an odd number of letters, right? So what will happen? So for example, if I do like it's not a word, but if I do ABCBA, that's a palindrome. So what will happen is that I will at some point get to the B's, right? This is the first, this is the last, and then they're each going to move up and down one, right? So first is going to move to here, and last is going to move to the same spot. They're both going to point at the C. Okay, now in this case, does it matter what this letter is? It could be C, it could be D, they're the same, right? So that is actually also a base case. When I only have one letter in the word, okay, when the one letter that I'm looking at, when first and last are the same, that's a palindrome, right? So this is sort of just breaking down all the situations. So in this case, when they cross over, or when they're on top of each other, both of those situations are going to be true cases. So what I could do is I could simply say, well, if uh, normally first is less than last, but when it's on top or they pass each other, then we can say it's true, right? So uh, if first index is uh, greater than or equal to last index, that will cover the situation when they're on top of each other as well as when they've passed each other. Then in those cases, this statement is we're going to return true. Okay. Sorry, C++ habits. Don't need the brackets here. So if these two are on top of each other or they've passed each other, then it was a palindrome. Okay, you wouldn't be able to get there otherwise. And finally, the last one is else. By the way, this didn't have to be an else if. This could have been just an if. You do have to be a little bit careful. I kind of like to think of these as mutually exclusive, which is why I do if, else, if. There are some cases where it's if. It depends on what you're trying to check. So in this case, this is an else. What do we do with the else? This is return. We're going to be returning. Well, it depends on what the function, the rest of the letters are. Okay. So we know that it is definitely going to be the same. Otherwise, we would have caught it here. We know that they haven't gone past each other. So now we only have to do one more check. So we don't even need to do this check because if it was not the same, we would have already stopped it here. So this one means that those two are the same and the indexes haven't crossed. So all we have to do is check the rest. So this would be check palindrome. Take the word, pass in first index +1 and last index -1, and that will get you the right results. Okay? So this is how it works. I assume that my function already worked, and it does. Okay? And so all we need to do is make the function call. And if the function call returns true, then it's true. And if the function call returns false, then it's false. Okay? I've made the check for this one situation. Okay? Sort of as part of the else. But that's how I would do it. Okay? Now, I'm going to share with you a secret passed down to me by my professor. Okay, my professor told me the secret to recursion. Okay, and this is something that I want to share with all of you here. There is a secret. Okay, here it is. Recursion works by magic. That's the secret. Okay, recursion works by magic. Okay, so here's the thing, like when I when I first heard this, I was like, that's a load of crap, right? Like, what the heck? That's this. There's no reason that this is true, right? So it's kind of like a joke. But I've since been convinced that this is not actually wrong. This is actually true. Recursion does work by magic. What is the basis of all magic? It is belief, belief in the unbelievable, right? So if you think about recursion, you have a function that you have to believe works. My function works. My factorial function works. And if it works, you can call it, right? It's kind of like you never question whether the print function works or the square root function works, right? You just assume it works and you call it, and it gives you an answer like magic. See? You have to now say, my function works, and the rest will just work. Okay? So I'm going to leave you with this idea. In the end, you just really need to do a lot of practice to see how this works. So hopefully this was useful. Bye, everyone.